Next, we're going to be applying some of the area formulas to um, quadratics. So, but before we get started, I want to run through what the area formulas are and what each figure looks like, so you can make sure you're drawing the correct figures. So first, for a rectangle, all right, you have 4 right angles and then opposite sides that are parallel. The formula for an area of a rectangle is the area equals the length times the width, or the base times the height. So here we'd have the width, the shorter side, and our length, the longer side. Next, for a triangle, all right, you can draw the triangle any old way. All right, for the triangle, the area will equal 1/2 the base times the height. So here is the height, and here is my base. Base is this whole side, our height is right here. Next, for a parallelogram, all right, parallelogram has opposite sides that are parallel. All right, this right here, this dashed line is the height. This whole bottom side is the base. The area will equal the base times the height. All right, moving on. A trapezoid is also a quadrilateral with 2 parallel sides. So the top and the bottom are parallel. Then there are 2 other sides that are not parallel. So these 2 sides right here are parallel. We call this base 1 and this base 2. There are 2 bases. And then this is our height. The formula for the area of a trapezoid is area equals 1/2 base 1 plus base 2 times the height. The average of the bases times the height. Next, a rhombus is a quadrilateral with 4 congruent sides. All right, 4 congruent sides. But you don't necessarily know that all the angles are 90. It's just 4 congruent sides. The formula for the area of a rhombus is the area equals 1/2 diagonal 1 times diagonal 2. What I mean by that is this is my first diagonal from vertex to vertex. This is my second diagonal. I'm going to get a marker real quick to highlight those. All right. So here is diagonal 1. And then here is diagonal 2. All right, diagonal 1 is right here. It actually doesn't matter which one's D1, D2, and this is diagonal 2. All right, so to find the area, you take half the product of the diagonals. And then last, we have a circle. All right, the area will equal pi r squared. Now, I do expect you to have all of these formulas memorized. You'll see them again and again and again, and you should have all of these memorized. Now, let's go ahead and do an application problem with area, and talking about the formulas. Now, what I want to highlight is each application problem will be a little bit different, so you're going to have to use a different figure or different rectangle for each application. Now, first one, the length of a rectangle is 6 more than its width. The area is 91 square inches. Find the dimensions of the rectangle. Now, this is a geometry problem, so the first thing you should do is draw the figure. In the problem, figure out the figure they're talking about. They're talking about a rectangle. So I know that I should draw a rectangle. Now, go ahead and label the rectangle. The length is the longer side. The width is this side. Now it says, we know our formula is area equals length times width. Next, it says the length is 6 more than the width. So I know my length is 6 more than the width. So now from here, after you draw the figure and label, you need to figure out or set up a quadratic equation. All right, so for our equation, I know the area equals the length times the width. All right, my length is the quantity W plus 6. My width is just W, and my area is 91. So I'm going to plug 91 in for A. The quantity W plus 6 in for the length, and W in for the width. Next, let's solve this equation. All right, so when we solve, we'll have 91 equals the quantity W plus 6 times W. Distribute the W in. 91 equals W squared plus 6W. This is a quadratic equation, so let's get 0 on one side. 0 equals W squared plus 6W minus 91. Let's just solve it by factoring. The factors of negative 91 that add up to 6 are 13 and negative 7. So we'll go and factor. 0 equals the quantity W plus 13 times the quantity W minus 7. Apply the zero product property. So W equals negative 13 or W equals 7. Width, or the width of a rectangle, cannot be negative. So what I'm going to do is I know that this solution does not make sense because you cannot have a negative width. Now, from here, I know my width is 7. We have to find the length now. All right, so 4, find the length. I know my length was the quantity W plus 6. So we'll have 7 plus 6 or 13. So the dimensions are 7 and 13. So you could even finish it with the complete sentence. The length is 13 and width is 7.